Hey, good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is CSharpFritz, and this is C Sharp with CSharpFritz. It is so good to see you. How you doing there, chat room? I see a couple folks wandering in. Hello, hello. I'm going to say hello to Rick is here. Jose Grande Jalapeno is here. Hello, hello. Shy Sharp, good afternoon to you. It's all nice and sunny outside here in Philadelphia. Let's take a look there in the chat room. There they are. There's a couple of our friends, and I see some more folks wandering in here. We've got an interesting topic today. I'm really looking forward to this one. We're going to get into some of the more abstract, some of the more interesting topics of object-oriented programming today. And we're going to talk about abstract classes, interfaces, and even more so, we're going to get into error handling, which is a topic that we've kind of skipped over up to this point. We haven't really gotten into it, but we're gonna get in there. We're gonna take a look and talk about what's involved in preventing our applications from throwing errors. How do we keep these things running cleanly and safely as they're running? So I've got a Jupyter notebook all made up that we're going to go through today, and we're going to discuss and get into all the cool things around inheritance and defining and building these more complex structures. So we're really looking forward to this with you today, and I'm trying to hold out and see if we get any more folks wander in here before we really get started. I am going to get some music playing here in the background. This is, of course, we've been using Stream Beats from our friend Harris Heller. Let's get that started. There we go. And this is called Synthwave from Harris's Stream Beats playlists. So you can find these on YouTube, on Spotify, everywhere that you can find music, on Twitch, on YouTube, everywhere out there on the web, even Apple Music. Check it out. This music is free to use. It's free to embed on your YouTube videos, your Twitch streams, wherever you might be. And thank you so much, Harris. We appreciate you sharing the music so that we can use it live on stream. There we go. All right. How you doing, chat room? So We've been talking through a whole bunch of different topics, and last week we even had our errata show. Let me head over and show you the GitHub repository. We'll talk through where we are, where we're going, and what's up on deck for today's stream. So let me head over there, and we'll take a look. Here we go. So there's GitHub. This is the GitHub repository that we're using for everything about the stream here. Let me share this link in chat. So if you want to follow along, you can click in there. You can get into our Jupyter notebooks that we're going to be using for the entire stream today. Interacting, it's going to be your opportunity to tinker with some of those things that are going on and try out, modify the code in the samples and see how it works for you live in your browser. And I've got a link just below here at the top of the README. You can launch a binder. You can launch a Jupyter Notebook binder and get right into exactly the code that we're going to be executing here live on stream. Or if you're watching the YouTube video recording, you're going to find all the latest updates inside this binder that you can use and learn from. Doesn't matter if you're on a phone, if you're on a tablet, or if you're on a PC like I am here. Now, we've been going along. You can also run these notebooks locally if you're on a PC, maybe you're on a Mac or on a Linux machine. You can clone this repository, execute the docker compose up command if you have Docker installed, and you'll be running the notebooks live locally. I've updated the version of .NET Interactive that powers our Jupyter notebooks, so you're going to see, you're not necessarily going to see new features, but if you are using the local copies of these, you're going to want to get a new instance. You're going to want to pull a new copy from my repository so you get the latest version of .NET Interactive installed. Hey, our friends Stelzy and Freljung are here. Varla Tang, hello, welcome in. Good to see you. Now, all of the notebooks are sitting here inside of the notebooks folder, and you're welcome to click through and see exactly what we have. There's 8 notebooks here with all the lessons that we've done up to this point. And I have the projects tab up here that shows you here's what we're working on and some of the sessions that we have planned going forward. So, error handling exceptions, interfaces, and abstract classes, that's what we're doing today. We covered all of these other topics as part of our errata show that we did last week to kind of fill in the gaps, to go back and plug some of the holes for some of the things that we had covered and answer some further questions that folks had at that point. So coming up, we're going to talk about dependency injection. We're going to talk about unit testing. And we've got some other issues. We've got some other questions, some other topics that folks would like us to take a look at. Including talking about null references and how we manage that. Some class design practices, working with attributes. And a big topic that we get a lot is about asking about C# 9 features. And I think we're going to do C# 9 features in that first or second show that we do in November. All right. So those are some of the topics that are out there. There is a question, there is an open question here about the user interface frameworks. And which user interface framework do you want me to start showing first when we get done talking about class design basics, working with C#, and we start to get into more of .NET and building applications? So this is issue number 13, and so far Blazor looks like it's in the lead with 34 votes. Please click through and give a thumbs up on the comment on the framework that you want us to talk about first. It looks like we're going to talk about Blazor, maybe a little ASP.NET Core, and then Xamarin, WPF, Windows Forms after that. There's a comment here, maybe Avalonia. Clearly it's behind, but if that's something you're interested in, let me know. Click through and give a thumbs up on the user interface framework that you're interested in seeing. There's a question here in chat. Let me bring up, I didn't open featured chat before I got started here. Let me get this open. And I will drop this. That's not right. That's not right. I want to be... Come here, you. It's trying to log me in with the wrong account. 1 second. And I do the 2-factor authentication. Like every good developer does, I do 2-factor authentication for all the systems that I interact with. And there we go. Fantastic. Here it is. So Ruans asks, hey, can you share a link for the older episodes that we've gone through here? Absolutely. You can find this on the YouTube.net channel. Let me grab that channel real quick. And there is a playlist that you can find. Scrolling down here, I don't believe it's on the front page. No. If you go into the playlists that are available here, there you go, Learn C# with CSharpFritz. And the entire playlist, all 7 episodes so far, are right here. You can click through and learn more about... Where's the screenshot for that one? Come on. So, they're all there. You can click through, you can learn more and follow along, and there's links. And inside of our Jupyter Notebooks, we continue to build out our collection of different lessons that we've learned along the way. So, so you can start there at youtube.com/.net. Click the playlist and you'll find it right there. All right. Let's see what else we have. PyroCat, hello, welcome in. All right. So this was from session 1 down here. 0108 is where we're going to be today. This one, 0108. Open that one. There we go. So we're going to talk about abstract classes, interfaces, and error handling. And this is where we get into some very interesting topics. This is something that I think gets into object-oriented programming concepts and design principles that folks can either get really opinionated on or just completely skip over and not care about. And to each their own. You can do these several different ways, and really this is a little bit of where programming becomes an art form, because you don't have to do these things everywhere. You're going to be kind of forced into it in some places when you want to build with some of those user interface frameworks, and you want to declare that you're building a web page, you're building a Blazor component, you're building a Xamarin page that's going to appear on someone's phone. When you're working with those, you do have to adhere to a little bit of it, but building and extending your own abstract classes and interfaces, you don't always have to do. Error handling, you always have to do that. Nobody should tell you don't have to do error handling. Nobody's perfect. You're always going to need some level of error handling. There's a question here from Nothing Else Matters. It's a little bit off topic. And it's actually talking a little bit about reflection. Frau Young already has the answer to it here, but I'm going to bring this up. I'll address this here. I've been working with a generic function, and I need to make an instance of the generic object, and we're going to call it T01 as the type. Is that a good way to use the activator create instance? So activator triggers something called reflection, and reflection is a way for you to take in a type, an explicit type that you want to interact with, and you can create an instance of that type using this activator create instance syntax. While that's possible, and default will give you the default type of that type, there is a new syntax that Frau Young highlights here in the reply, and this is the correct answer. Just say new equals new, and it will create a new instance of that object. So, or return new, one of those. So, not bad to do. Easier to work with. Yeah, PyroCat is super opinionated. And as we get into this topic and we get into this notebook today, I want to encourage you, friends. It's okay to be super opinionated. It's okay to really have strong beliefs about how folks should work with their code and how they should structure things. That's okay. What's not okay is to tell somebody that they're wrong because they don't hold those same opinions that you do. They're opinions. There's good practices, there's better practices, but not everybody has to do all those things. There's a time and place for every technique that we use in programming. Some are appropriate, some are not. What is appropriate, what is the number one mission, if you will, is shipping code. If you ship code that works, that solves someone's problem, it's not all that bad. All of our code can be improved at some point, at some time. The question is it worthwhile? Does that deliver additional business value? So, we're going to take a look at different things here. We're going to discuss and go into this, and we're going to see different ways to do different things. You don't have to do all of these things. So, all right. Absolutely. All code can be improved over time. And let me tell you, if you're a new programmer, one of the first things that you're going to learn is in about 2 weeks after you finish writing some code. It might even be a week later. It might even be later the same day. You're going to come back and look at a program. You're going to look at a library, a file that you wrote, and at some point you're going to say, "Wow, who was the moron that wrote this? Who was the goofball that went and programmed this stuff? I can do better. I have a different way that I think through those techniques now." And this happens to everybody. You're going to run into it, and you're going to figure out how to make your code better in the long run. And that's part of what experience is. Making your code better. Hey, our friend Layla Codes It is here. Hello. Good morning. Every code is very unique and has very strong opinions. Yep. Understanding that properly is how good teams form. And that's why it's good to have a diverse set of opinions and experiences on a team because of programmers, because you will figure out what is the best way to do something. Let's talk about abstract classes today. So we've seen a little bit in some of our previous episodes where we've started to inherit or implement different things. And we learned way back at the beginning in episode 1 that everything in C# is an object. And object is the base type for everything in C#. But you can define things that are objects before whatever object it is that you want to work with. So I can create abstract classes. This is a class that you can't create directly, but you can implement. You can define that is a relationship between one class and another. So a good example that I've seen a number of folks use in other locations, and I wanted to bring it here, is the shape example. Now, this is a very basic example to get past this object-oriented discussion, but you'll see we can get into some other more program-friendly things than just shapes. But maybe shapes are important because you want to draw shapes on screen. Don't know. So if I define a class called shape, I can say that that's an abstract class, and I can't create a shape class, but I can define additional classes, triangle, rectangle, and square, that do implement the shape class. Now, that's fine. I think that, let me know if the zoom in level is good there for you. I've changed resolution on my screen here a few days ago, and I want to make sure I get this right for you. So I can create a triangle, I can create a rectangle, I can create a square, and these are just fine, right? I can say var t equals a new triangle, and that works, but I can't say var t equals a new shape, because it's an abstract class. It's something that you're not allowed to create. So this is a way for you to kind of hide whatever that object is, right? It is a shape. I've exposed that shape object so that other places, other libraries, other projects can consume that, right? Especially if I make this public, right? Now it can be used in other libraries and other places, right? And other folks can then make their own shapes on top of that if they'd like. But I can provide these three and move forward. So we've typically seen, right, we've said var t equals new triangle, and that works, right? If I just put a display here, just so that we show that we didn't get an error condition being thrown here. Or we would also declare a variable and specify exactly the type. Well, that's not how you spell triangle. And we would receive that type, right? That's when we did var, it was a shortcut for, well, here's what's on the right side. New triangle, well, it's a triangle over here. But you can also specify that this isn't just a triangle. You can also specify that it's a shape. So I've created a new triangle, and when I go forward and use that later on, right? It is a triangle, but I can work with it as a shape. It only knows about it as a shape. It's only exposed the surface area of the shape. Let's talk about that, the surface area of the shape. And I see a couple of really good questions coming through in comments here. And let me come to this question from Nilium. I hope I pronounced that right. Let me know, and I'll correct that. Abstract classes, shouldn't they have at least one abstract method? Not necessarily. It's not required by the programming language or by the compiler. By the programming language, the compiler, or the framework. Right? You don't need to do that. In this way, I've created effectively a marker, right? I've created a marker that says triangle, rectangle, and square are shapes. Shape doesn't actually do anything. You're right. And if we do want to provide some value to that shape, we should include either abstract methods, abstract properties, and we don't even have to provide abstract versions of those. We can provide concrete properties and methods. So let's dig into this a little more. Nilium has provided a really nice segue here to the next sample here. Let me dig in there. Yes, it does depend on the language. In C#, not required. So I can provide methods like perimeter and area. And in this case, I've made these concrete methods. I can also provide a property. Let's provide a property here. Public. Now, let me hold off on this one. Let me hold off on. No. I'll do it. I'll put it in here. And let's say number of sides, and I'm going to return 5. It's not necessarily accurate. Oops, I forgot a get. There we go. So we have an abstract class shape, and we've defined a method called perimeter, a method called area, and they return static values, right? They return with the constant 10, 15, and there's always 5 is the number of sides. So I can create a new triangle, and the area, well, is always 15. So a triangle calculates its area differently from a square, from a rectangle. So we want to provide that same, I want to be careful how I say this, that same footprint to our shape class. I would say it's the shape of the shape class, but that sounds weird. The same footprint, the same signature, where I do want to have an area, I do want to have a perimeter method, and maybe I do want to have a number of sides property. But they're calculated differently for each one of our shapes. So let's take another step or two in here. We can mark our methods and properties with the abstract keyword as well and force those to be implemented in our classes. Okay. So I'm going to continue talking about that shape class, and I'll have now an abstract perimeter and an abstract area because they're calculated differently. So I'll have a triangle, and a triangle has 3 sides, so I'll create 3 properties. These are fields here, but they're public fields. No big deal. But I've created these 3 in addition to what the shape defines, and now I override those abstract methods. I'm overriding perimeter, and here's how you calculate perimeter for a triangle. Area for a triangle, when we know the 3 sides, we can use Heron's formula that takes in the semi-perimeter, that's half the perimeter, and takes the square root of that semi-perimeter times each one of the difference of the semi-perimeter in each one of the lengths. And you can scroll over here and see how I added all of Heron's formula in here. Of course, we know rectangles and squares calculated differently. We have our length and width, and perimeter is length times 2 plus width times 2, or length times width. And of course, a square is just a rectangle that has length and width that are the same. So right? That's a great way to describe it. Our friend Layla here refers to the properties and the methods here. These are shared common attributes. That's a nice way to describe it. Yeah, absolutely. So if we create a new triangle with these three sides, it's a 3, 4, 5 triangle. That's a classic right triangle. We can display the area. The area is 6, and the perimeter is 12. 3 plus 4 plus 5, 12. Not bad, easy to do. But maybe I don't have a triangle, right? Maybe T is a rectangle, right? And the length of our rectangle is 10, and the width of our rectangle is 5. I don't have to change display T area and T perimeter. It still works. Now I have some warnings down here because the triangle fields were never assigned to. I could make these, simplify that a little bit, and make these get set, right? Make these into real properties. And that makes that warning go away. So it's still a rectangle here, and I'm still behaving and interacting with those methods the same way. Once again, I should have made those properties so I didn't have any warnings. Okay, so we can generically interact with, generic is, I don't want to use that. We can abstractly interact with the area and perimeter methods, and depending on what type of shape is injected, it'll be calculated appropriately and differently for those. And that kind of makes sense, right? As you're building and you're working with these different types, they have that same common method that we can work with. So let's go a little bit further here, right? So if we declare variables or parameters of that base type of shape type, right, we can assign the derived type. And you saw me do this up at the top, right? So if I receive shape of type S, a shape variable called S, and we put a rectangle in there, we can display the area, right, just by saying s.area. But we can also then use the is operator to test if that shape is of the descendant type, right? We can inspect and learn a little bit more, and maybe we want to cast that back to a different type. So check this out. So I wrote a little method called is quadrilateral, right? Quadrilateral, is this a four-sided polygon, right? That's what a quadrilateral is. Thinking back to Geometry 101. I define a shape called T, and that's a new triangle in this case, and I'm going to display, well, is the rectangle, is this a quadrilateral? And rectangle up here is S. I'll pass in is quadrilateral, triangle is quadrilateral, and I'll pass in my triangle down here. And of course, it says a rectangle is four-sided, a triangle is not. If I change this to a square is a rectangle, because square implements rectangle, rectangle implements shape. So a square, right, here's the hierarchy. It's not looking up just to the previous thing implemented, but it goes up the entire stack. So I can test to see any of those items. Is it a rectangle? Is it a shape? And return that appropriately. Interact with that. You're right, Stelzy, you can do that. I didn't want to get into angles. If you have at least one side and one angle, you can pretty much figure out the rest of the triangle. You can do that, but there's a little bit of trigonometry involved. Didn't want to get too far down into the weeds on the sample, you know what I'm saying? Wanted to focus more on the code than the geometry, but absolutely, trigonometry, you can figure out all that stuff. Cosines and sines, I forget exactly what the formula is, but it's out there. You can look it up if you want to get a little bit more complex. So we've defined abstract methods, and we override them up here. So, oh yes, SOHCAHTOA, that's right. Oh my goodness, there's the trigonometry hints that I've forgotten from days gone by. All right, those, yeah. So if we make things virtual, we can provide a base implementation and then hide it or override it later using the override or new keyword. So, this is an interesting way for you to say, well, this behaves differently from those other things. There's a default implementation, but it behaves a little bit differently. So let's take our shape class, and we still have perimeter and area. And in this case, we'll define area is virtual. Virtual lets us provide an initial default implementation, length times width. Now, that works pretty good for the quadrilaterals, for the rectangle and square, not so much for the triangle. So I've still implemented perimeter there, I implement area, and if I let this go, if I execute this the way that it's defined right now, I didn't put any keyword with that, and it hides the area method on shape. It doesn't know what to do with it, right? Because shape has area defined. This has area defined. You don't, because it's marked virtual, you don't need to implement the area. So it can be derived, right? It can be pulled out of that abstract class because it's sitting there, it's virtual. But I can do other things in there if I'd like. I can override decimal area, right? And right, I could do something in here if I'd like. Hey, you get back over here. Get back over here, right? I could say calculating area for a rectangle, and I can then call the base method and return that. Now it's a little bit interesting. Now if I say var t equals new rectangle down here, and we say length equals 10, width equals 5, and execute that. Now, when it calculated area, it executed my calculating area for a rectangle. And then it ran through and actually executed the base area calculation here and returned that value. Now we're talking. Now that's a thing. Sure, I will share the link to the GitHub repository. There you go. Hey, Chicken Man is here. Finally caught live the C# with CSharpFritz stream. Well, welcome in. Nice to meet you, Chicken Man. Thank you for tuning in. So, right, this is a way for you to provide those default implementations, that base thing that you want. All, in this case, all shapes can calculate area, and they have some length and width. That's probably not the best place to put it. Here is to put that area, right? Because it's not always length times width, right? There's some other funny things that you may want to do. So, and of course I've got the same get set issue here again. Let's fix that so we can get rid of these compiler errors. No, compiler warnings. Nobody likes compiler warnings. There we go. All right. Now, what if you have methods in here that you don't, or properties that you don't want folks to be able to implement? And let me pause for a second here. Let me pause. Stelzy just brought up a very good Very, very good point here in chat. Let's go to Stelzy's comment here. Now the fun begins when you introduce a circle. Yes, right? We can define round shapes, and then we can get into ellipses and parabolas, right? Ovals. So there's a whole different thing that happens there. So maybe we want to have shape and polygon becomes triangle and rectangle and square. Absolutely, right? You start running into some interesting things when you deal with, right, these other objects that clearly violate what you intend. So, all right. If you have classes or methods that you don't want to be implemented, you want to protect them and say nothing can descend from this, right? Because you even saw, right, even though rectangle isn't abstract, I'm able to inherit from it as a square, because a square is a rectangle that has four sides that are all the same length. But if I don't want that class to be able to be re-implemented, so if I have shape with perimeter and area, let me put that get set on these. I can still have my square as a rectangle, right? And I can mark it now as sealed, and it will prevent the square from saying that it's a rectangle, right? So if we label this rectangle as sealed, re-execute, sorry, you can't derive from that. And this is a good way for you to protect business logic from being attached onto, right, or interacted with from other classes, right? There's some internal logic there that should not be modified, should not be accessed and interacted with. Instead, we mark it as sealed so that other projects, other assemblies, other applications that might reference this cannot interact with it. Yes, we're clearly live here. Absolutely. Take care, Layla. Thanks for stopping in. So we'll get into, right, there is a request out here for a future episode to talk about class design and some of the things you might work with there. And we'll see what that looks like in the future. Now, I don't think I didn't go back in and talk about, well, I'm sorry. Let's do this. I'm going to turn off there. And if I let this go again, right, because rectangle is no longer sealed, I can re-implement that. Well, I can also specify something is sealed and overrides a method. Consequently, then, I can't re-implement area inside of square. I've protected this and said this is the way that all rectangles, all future rectangles, will calculate their area. You can't re-implement this and change the behavior of the area method. Now, and I used the keyword there, protected. I don't think I didn't. I didn't get back into the protected keyword. We learned about protected as a scope that you can apply to things inside your class to prevent, to only allow descending objects from being able to interact with that. So maybe I set up a protected property up here, right? I don't know. Maybe this is a string and we call it a name, right? And inside of rectangle, right, maybe let's create a constructor for rectangle, right? So if we say public rectangle, I can say here, name equals rectangle. Heck, let's go kind of off the charts here. Let's call the rectangle Skippy. We have Skippy the rectangle. Consequently, then, if I want to go down here and interact with that name object, I can't, because name is only available as protected inside of the shape. Other shapes can see it, right? Other things that inherit can interact with that. But we, outside of that, as folks that are declaring a new square, cannot interact with it. Does that make sense? So these are ways for you to protect internal features, expose them so that other classes, other objects that do inherit, that do implement that object, can appropriately interact with them, set those values, so that a virtual method elsewhere, an abstract method that's implemented elsewhere, is able to reach in and interact with those values. So these are ways to guide your developers. That's right, Jason. Ways to guide your developers, guide those folks who are consuming your objects, your software development kit, so that they're using it appropriately. And they don't touch some of that business logic that they don't have any business changing, right? If you were creating a way to connect to a database, the way that it communicates, the protocol discussion across, the protocol conversation across the network from your machine to that database doesn't need to be touched. It's not something that the developer who's using the database connection needs to be concerned with. They're using that, and it can just be handed off. All right. So this is all about making things appropriately available to those folks that need it, and hiding those things that should not be modified. All right. Now, that's the ISA interface. The ISA interaction. We also have these things called interfaces. And we saw this with IEnumerable of type T when we were doing collections and link about a month ago. Now, interfaces define common methods, properties, events, indexers, that signature for an object that your class or struct will implement, right? So if you define an interface, and I'm going to define one here called iLogger, and by convention, C# folks, .NET folks will name their interfaces starting with the letter I. Many folks do this. There are some folks that do not. It's strictly a preference, but you will see a lot of folks use the I prefix to indicate that it is an interface when you're working with it. Now, you can't create an instance of an interface, but you can create a class that implements that interface. And just as we saw up here, abstract classes, we use the colon and then the name of that class that you're implementing, that you're inheriting from. When you're implementing an interface, when you're saying this object has that interface, you use that same colon notation. And you can implement several interfaces, not just one. You just separate them with commas, and you can implement many of these. So I'm going to define a logger interface, iLogger, right? And because it's called iLogger, I know it's an interface just by looking at the name of it, and I can't create a new iLogger, right? I can't say var l equals new iLogger, right? That's going to error out for me. If I scroll down here, you can't create that. So you're kind of preventing folks from falling into this trap of, sorry, that's an interface. You can't create that. But I'm going to create this logger interface, and it has a method, log error, and it has a property, error count. And I'm only implementing the get of the property. When you're working with the logger, you outside the logger aren't allowed to set the value of the error count. So that's going to be done elsewhere, and it's going to be provided to you as a read-only value that you can interact with. Now, let's talk about this. I'm going to create a logger here called display logger, and I'm going to create an error count that I'm going to hide behind the scenes. And whenever you call log error, I'll display that error. There was an error, and here's what that message was that you're passing me, and increment the number of errors. My error count then just returns the error count in that static value. Now, the reason I use a static here is that way I can create multiple display loggers, and it will always have that incrementing error count. It's a very simplistic implementation. It's not something that you're going to end up using in a production space, but just simple to show how this works. Yes, Stelzy points out, members in interfaces are public by default. So I can't change this from, right? So I got rid of that new, right? I have a display error count method here that takes an iLogger and will return logger.errorCount. Maybe it does something else. But I'm going to log an error, Houston, we have a problem. And no, change that from DB logger to display logger. There we go. There was an error, Houston, we have a problem, and I have one error. I also define a database logger here just so I can show a second one of these. And it implements the same two methods, but maybe it reaches out to a database to log the error. And actually queries the database for the count of errors. So while I can do display logger and it behaves and shows and displays appropriately, I can use a DB logger and it will tell me, oh, that was logged to the database, and I don't know how to query the database, so I'm just going to return a 0. Now, to show that, yeah, these are public by default, I can't change this to private because it's not publicly accessible, right? This is called an implicit implementation of the interface by making those properties, methods, events, indexers of the interface with the exact same name, the exact same signature, returns the same value from a method, takes the same arguments of the same type, and it effectively looks the same as the interface up there. I can change the name of this input argument, right? I can do that and it works just fine. I'll change that back to display error. Helps if I spell, there we go. Okay. The names of your parameters, right? Those variable names, they can be whatever. But the interaction with them, the signature, the types of both the parameters and the output value have to match. Now, that's nice if you want to define something that is everybody's going to have, everybody's going to see, and it's always going to be accessible to all the things. But sometimes you want to hide that a class implements a specific interface. I don't run into this too often, but you can create what's called an explicit implementation. So if I create an interface called I do a thing, see what I did there? I do a thing. And it has a method in it called do the thing. I can then create a class, public thing, that implements it implicitly. Public void do the thing. It has the same signature here. Display, I did the thing. But I can also explicitly implement that interface by prefixing the names of my methods, my properties, with I do a thing. Ah, now we're talking. Now we've got a thing here. So if I have I do a thing, do the thing, we'll output I did a thing. So here, P equals a new public thing. P, do the thing, and it did the thing. If I change this to secret thing, well, it doesn't know how to do that because it's a secret thing. and it's been explicitly implemented there. We've hidden that implementation detail. I can get back into it though by changing my var to I do a thing, and now it knows that that's an I do a thing object, and it knows that it can call the do the thing method. Right? So I've hidden it so it's only exposed when it's referenced as the interface type. Similarly, if I make this a var, right, it breaks again, but I can make this, cast it explicitly at the time I want to call it, and it will do that other thing. So, different ways to access those various methods, properties, events, indexers by using this explicit implementation means you get to hide them. Really cool stuff, and shows some interesting flexibility in the C# language. This isn't something typically that I use, like I said, in my programs, but there may be places that this is appropriate to do a little bit of obfuscation of the intent of some of your objects. Sorry there, friend, we're talking about C# today. There are other folks that are teaching JavaScript over on the Microsoft Developer channel and on Microsoft Learn. So, there's a question here from Boomy. Do I have a real-world example of when you would want to do this? Some places where I have seen some of this done are around some of the lower-level interactions with the user interface. Somebody will create an object of type component, of type form, page, and for us as the outside developers, right, that are implementing and consuming that, you're going to work with those various properties and things on the form and the page. However, when the renderer that's going to turn that page, that form, that component into HTML markup, or compile it into appropriate Objective-C code so that it can be turned into an iPhone application, right? As it goes through that process, it's going to cast it to a explicitly implemented interface so that those methods and those things that will help format and output for what the renderer needs are now accessible to that object. So, like I said, it's a way to hide some of that implementation. And when you think about it, us as developers, I don't care how you're generating your angle brackets for HTML. I don't care how you're generating the code for Xamarin and an iOS app or an Android app. The way that it's being delivered to me, the way that I'm working with it, those are concerns that I assume are just working properly and I don't need to override. So, you never even knew this was possible. Yeah, Boomy. You know what? And this is, right, some of the reasons why it's interesting to go back and take a little bit of a refresher. Just take a glance over some of the documentation from way back in the day, because there might be something in there that's valuable to you that you can interact with. Now, a feature that was introduced in C# 8, so this has only been available for the last year or two, something called default implementations of an interface. Now, this sounds weird. Default implementation of an interface. If you declare an interface and you start interacting with it, at some point you may want to create a new version of it. And interfaces can inherit from other interfaces. Well, when you start inheriting from those others, you may want to provide a default implementation that inherits, that defines, here's the way this should behave by default. Let me show you. So we had I do a thing, and it has a void here, do the thing. So maybe I want to create version 2. And I do a thing 2 has do something else. But because it also implements I do a thing, because we've extended the interface now, I'm going to explicitly implement the I do a thing, do the thing method inside the interface. So, that's right, Surly Dev. I make the thing from the previous version. I'll provide a default implementation of here's what it could do for version 2. And I can now implement do something else here. The only thing that I really want to use from I do a thing 2. And I can continue working here and display something else. So if I can create new thing, right here it is, and say do something else, and that works. That works. I can also attempt to create, right? If I turn this around and I say, well, because it implements all of the I do a thing things, right? I can say I do a thing, right? No, let me back up. Let me show you what happens if I say P do the thing. It doesn't contain a definition for it because we have this explicit implementation here, right? So, and I'm kind of mixing things here. I may have made this a little bit more complicated than I needed to. You do all the things, Pyro Cat. There you go. Someone could go back to a previous version, right? So, if we want to pass in, right? So, if we want to interact with I do a things, right? Now it does support that. Okay. I could provide a default implementation here for this as well, right? I could say did the default other thing, right? And if I didn't implement this, yeah, that doesn't work. Control KC doesn't work. Right? So this is my default thing. That still works. Right? And if this is I do a thing too, did the default other thing because it's not implemented, right? So if we put that back in there, it did something else. Ah. So now we've got some flexibility and we can help make versioning our interfaces something that's valuable and worthwhile. Now, I can't do this, right? Because it doesn't pick up that interface has been handled properly, has been implemented properly, right? So I need to, in this case, I need to hide it, the way that I'm interacting with it. But, right, we've provided this default definition. And Boomy, you're absolutely right there. Your legacy code that's still out there, that's still running and has been out there for years and years, implements I do a thing. But because you're adding some new feature, now your new stuff implements I do a thing too. And you can consequently pass those new things, those new I do a things, into methods where I do a thing was supported. So, right, if I create a method here, let's create a method here. I'm going to turn this into a var. And if I go down here, void do something with that thing that time with a really long method name. You can do this. That is possible. Okay? And that's a made up and terrible name. Right, so if I create this and I want to say you know, heck, just make this really easy and say do the thing, right? Just to show that this is possible. Right? Well, new thing implements I do thing too, and if I pass in P, which is a new thing, oh, I forgot. I gotta put that back in. There it is. The name do the thing does not exist. Oh, sorry. There we go. Right, and comment this one out. There it is. So it executed and returned the default implementation because it passed in I do a thing here. Yes, there are patterns and definitions, and we should talk about those more when we get into class design, but you'll see a little bit of this is called the strategy pattern, because you have different strategies, different ways that you're delegating and passing interactions into each other. But I'm taking something here that implements the second version of it, and it still works with that method that only knows how to interact with version 1. So interfaces can inherit from other interfaces. Classes, including abstract classes, can implement interfaces as well. Structs can implement interfaces. And now we have default implementations that we can pass around, reference, and return appropriately here. We could go back, you're right, Frau Young, I could go back to the I do a thing and add that default implementation up there so that it knows what do something else is. In this case where I'm versioning the interface, it didn't make sense to me to go back and re-implement that in the previous interface. So there it is, right? Now do something else. Should do the default thing. I'm not sure why that's not working. Because that should absolutely work, and it's does that need to be I do a thing too? There it is. Just because it's not referencing up into the interface, and I don't need that there. Now see, that time, now it works. Well, it's because it's this, right? So this object doesn't have these methods declared on it. You have to force it into the interface so it reaches into those interface types to be able to interact. Which, right? Now it knows how to do those. Now it sees those default implementations, and now it can interact with. Are we ever going to get closer? So this is an interesting question. Are we going to get closer to multiple inheritance? And this is the line that the C# program, the C# program managers and design team were tiptoeing up to. They didn't want to get to multiple inheritance, where one object can descend from multiple. You can only ever descend from one other class, but you can implement multiple interfaces. And as you're seeing here, these interfaces can now provide a little bit of implementation, but they don't know how to interact and reach into other things inside that interface. You run into limitations there where, right, if I do a thing too, if this also has a property called, let's put a property on here, name, the default other thing on, right, and let's, right, if I were to try and do that, that doesn't work. Oh, I need to implement, I'm sorry, I forgot to implement name. And I'll set a default value to that brave new thing. It can reach into that property and bring it out, right? I should make this private. It still works. So you do need to be careful what this interacts with, what it reaches into, because you don't have it only knows how to touch the things that are here. You can't reach into or create new things for it to go and interact with, right? This is very superficial what it's interacting with here. So now this is, and you can run into some very interesting problems around interfaces and what they implement and what has default implementations and what does not. You may run into the diamond problem. So the diamond problem is potentially having interfaces that reference other interfaces, that implement other interfaces that have default implementations, and they collide. In which default implementation do you need to actually support? Oh, I didn't provide the link back to default implementations by default. Oh, you're not gonna bring it up for me here. C# interface default implementation. No, not that. That wasn't it. This one. That's the proposal. Hang on. The actual definition of it is it going to be down in here? I think this is where we were. Let's find that. Explicit interface. Explicit interface. Default interface members. There it is. This isn't just proposed. This is implemented. This is done. But that's the documentation it's linking to. Let me link that here so that you have the definition of it. So you can jump right into the documentation. So there is a thing here about, where is it? The diamond. Yeah, diamond inheritance. Oh, they didn't show the diagram here. So diamond inheritance is oh my gosh, that's really confusing. You have these interfaces that have implementations defined. Well, what happens in this class, it implements all of those and has its own implementation. What do? You need to throw an error at that point. So when's this going to be uploaded to YouTube? A little bit later today. I try and edit and upload in the same day, but sometimes things come up and delay it just a little bit. Just a little bit. All right. So let's talk now about error handling. We've run into, I've shown you places where there's different errors that trigger here, but when an error fires in your application, it's actually a performance bottleneck. It slows things down, because now all of a sudden all those things that were running have to stop, and they have to handle that exception being pushed back up the call stack, right? The collection of methods that have called another and another and another. So they all need to be notified. Hey, there's a problem here. You need to do something about this. So let's take a look, right? If I do the very simple divide by 0, right? We get an exception thrown here, right? If I execute 4 divided by 2, I get 2, but if I change this to a 0, I get a divide by 0 exception returned, right? You can't divide by 0. That's an arithmetic thing that, of course, folks can't do. So, and you'll see here, it returns what's the call stack is what this is called. And it shows you, well, right, here's my method, submission 71. That's this block of code. The divide, we're inside the divide method, and inside of there is a division operation that's taking place, taking 2 decimal values, all right? And inside of that decimal object is where it threw the error. So I can see the entire stack here of exactly what happened, all the way out to, here's the script executing inside of my Jupyter Notebook. Now, we can prevent this. We can catch that error using a try-catch block. And try-catch you see in many other programming languages, and it's very similar here. We can work with this and behave appropriately, take appropriate steps with it. So if we use try and catch, we can wrap that code that we want to try executing and catch if an exception happens on those lines of code. So let's rewrite our divide method and return argument 1 divided by argument 2. And I've put a question mark here behind this to make it nullable so we can do some other fun things to break this. We'll catch specific types of exceptions, just like if-else-if syntax. You can catch different types of exceptions and it'll evaluate those top to bottom. So as it processes through it, okay, did we catch a divide by 0 exception? Yes. Okay, evaluate these lines of code and continue processing at the end. Was it a divide by 0 exception? No. All right, check the next catch. Well, there's no exception defined here, so this is the final catch-all catch block. So we'll evaluate this block of code instead. So I can now execute display, divide, and pass in my 2 arguments here, 4 and 2. Yes, E is used, declared but never used. I can get rid of that. There it is. Now, if I change that to a 0, right? Now I get the divide by 0 exception, attempted to divide by 0, and see, it should have dropped into there. Why didn't it drop into there? What did I break here? Return arg1 divided by arg2, catch, it should have dropped into there. You know what? When in doubt, restart the interpreter. Dude, come on. Kernel restarted, here we go. There we go. And wow, jumped all the way to the end. Thanks. So if I skip down to here, so here we go. Divide by 0 is not allowed. I display that, and no, it's still not showing it. It's, you don't like this, do you? Let's call this divide version 2, so we're sure we get the new method here. There we go. Now I'm catching that, and I can get rid of this, and I'm returning the value 0 just to return a value. I need to return a value from this. If I were to pass in null, well, I don't know what you did. I'm going to create some sort of an error message appropriate for my consumers of this method so they can do something, and I'm going to throw. Now, throw just takes that exception and sends it right back out so that everybody can see that. There is a comment here in chat from Jason, and I do agree with this. Never catch an exception unless you intend to do something with it. If you're going to what's called swallow an exception and do nothing with it, that doesn't benefit anybody, right? You need to notify, at the very least, notify your consumers that, hey, an exceptional scenario happened here. You need to go and address this. Now, that's a very good thing to do. There's other times where you're going to want to clean up the state of the method. You want to make sure that no resources are left in an untidy state, right? You want to make sure that things are back the way they should be. Nothing's mutated from the way that they were originally created and defined. So we can use something called a finally block. So finally is a selection. It's a block of statements that will execute no matter what after any of the catch statements were handled. So in this case, trying to do the division, catch, and I'm not specifying any exception here to receive, and finally cleaning up code. So when I execute this, divide cleanup, and I try and divide 4 by null, I get the you broke something else, and cleaning up code here is still output. So think about this, and I mentioned it here. If you're working with some external resource, maybe a file, maybe a database connection, you don't want to leave a reference to that file. You don't want to leave that file open, because then nothing else can interact with it if it errors out and doesn't appropriately release the interaction with that file. Yes, very good, Boomy. That's another good example. If you're working with an HTTP connection and there's an error, you would want to put a disconnect in the finally. Something happens while you're parsing, while you're reading data off of that connection to a web server, and there's an error. Well, you're still connected to the web server. When that error happens, you need to be a good steward for both yourself and your application, as well as the remote server, and disconnect. Ooh, I don't know what to do with this. Stop the connection, disconnect, break it, so that the web server can go do something else, and so that your application doesn't exhaust your network connections. All right. Great point there, Boomy. Thank you for sharing that. So, now, you don't necessarily have to catch in order to use a finally block, right? If I put this down here, no, let me put it back up there, right? I can comment out the catch entirely, and it will only clean up code. It won't do any kind of mediation in there, right? We won't try to handle that content. Instead, we'll just clean up appropriately. There might be an error here. If there is, go ahead and let it report the error, report the exception, and I know how to clean this up. I will clean up the state of this class with a finally block to interact with this. A couple of good questions coming through here. Let me queue these up and answer these. Let me see here. First question is from Spotagus. One thing I struggle with: when do you throw an exception, and when do you create a return object that has an unsuccessful property with the result? So this is a class design. type of scenario, right? This is a class design type of question. Use exceptions, and there's a comment here, and it's I agree with it. Use the exceptions when something exceptional happens, right? Something that, hey, this is broken, go do something else with this. You need to go and revert and notify the consumer that a problem happened. Think of it as an exception more like a problem. Now, using is successful, if you're using an is successful true false, right, a Boolean property, well, that may be appropriate if you're doing some sort of long math calculation, and it's possible that is successful is going to fail many times, and that's not an exceptional scenario, right? If it's okay for something to fail, for is successful to be false, right, that makes sense. Perhaps you have many different application servers and you want to go and interact with them, send them all notifications to update. Well, it may be false that it was unsuccessful at updating the application server because it was already updated. That's okay. That's not an exception. It was already updated by somebody else. So when you think about your business logic, your business processes, when is it appropriate to not be successful? That's okay. We know how to handle an unsuccessful scenario. And when is it an error? When is it an exceptional case? When something is broken, something didn't function properly, didn't function in the way that we expected. You need to go figure this out. The next question we have here is from Skywalker Force. So basically, Minecraft servers use this type of try-catch blocks for connection errors. Yes, that's a pretty good example. Absolutely. So when you start Minecraft and you go to connect to one of your favorite Minecraft servers, if something happens and it can't connect over the network, maybe the server is down, maybe there's something on your network that isn't getting you connected, maybe your Wi-Fi connection in your home is down, right? Or maybe you don't even have a Wi-Fi connection. It's going to try to connect to the server, receive some sort of exception. Oh, I can't see the server. Oh, the network connection is down. And that exception will be passed back to the Minecraft client, back to the Minecraft game, and it will tell you appropriately, based on what type of exception was raised, what the error is, so that hopefully you can take steps to remediate, right? Oh, my wireless is down. Oh, I forgot to turn on the wireless on my hotspot so that I can play Minecraft out in the park, out in the, wherever you may be. So absolutely, those things. It's a great example, and also shows a little bit of the next thing that I want to show you about creating your own exceptions. So it's one thing to have some of these default exceptions that we have here, like the invalid operation exception, right? Or there was a divide by zero exception here, right? And there's a couple other ones in here that you're going to see frequently. Argument exception, null reference exception, these things that are common throughout the .NET framework. But you can create your own exceptions that are specific to your business logic that you can use to raise and tell more information to your users, to your developers, so that they can interact with it, so they can take those steps. Wireless network is down. Your wireless network interface isn't active. Those are types of network exceptions that I would want to implement to be able to pass back and let you know, hey, you're trying to play Minecraft and the network isn't there. I don't know what to do with this. Go, and now we can pass that information. Now I, as the human interacting with the application, can take those steps that, oh, my network cable's unplugged. Let me go plug that back in. Oh, my hotspot needs to be turned on. Whatever it might be. So you create an exception by implementing the system exception base class. And there's typically 4 constructor signatures that are recommended that you implement. You don't have to do this, but these are recommended so that you adhere to good exception construction standards. So if I define the better division exception, because I want to pass around some additional information about it, I'm going to implement system exception and these 4 constructors. The better division exception with an empty set of parameters, better division exception with a message, better division exception with a message, and maybe an internal exception that actually triggered this one. We'll see how that can be used. And then there's this syntax that is used so that if we have to serialize and pass that exception object, right? We want to write serialization is the process from which we take an object in memory, a class or a struct, and we want to turn it into data that we're going to pass across the wire, we're going to save to disk, we're going to put it somewhere as text, as content, and then we'll reload it later back into, we'll deserialize it and turn it back into this class so that we can interact with it programmatically. Maybe we should have a session on serialization later. I think that might be a thing. I'm going to add into my exception here also, we'll have these 2 properties, dividend and divisor, so we can actually inspect what the operation was that was taking place. Now, by default here, it recommends that you pad the default syntax is, right, in our constructors, we can call down into other constructors by saying colon and base, and right, that'll go into our exceptions constructor that has this syntax. So I could pass nothing in, and it'll just create that exception. But I want to have a default message that says unable to divide by 0, so that by default, if you don't tell it what the message is, we'll get that reported. Now we can inspect and we can handle and we can raise exceptions of a type that make it clearer what happened. And as your applications, as your systems get much more complex, you're going to want to start creating exceptions, because your own exception classes, so that you can communicate to operators, to other developers, exactly why those things happened. So if I create a new division method, I'm going to call this one divide handled, I'll now inspect my arguments. If the second argument is null, throw a better division exception. So I create a new exception, a new instance of that class, and I'm going to specify this message and pass in the dividend and divisor appropriately. So then I can inspect it. Right? I can go further with it. I'm still going to do my return value here, but I've already done those inspections for the things that I think will be exceptional, those things that could be error scenarios, right? This is sometimes referred to as guardrails, because I'm handling those potential scenarios here and giving good information back to my other developers, back to my consumers, so that they know why that happened. Now, I don't necessarily have to define, right? Since I know unable to divide by 0 is my default message here, I don't have to give it this message. And if I execute here, I can say try display divide handled and try to divide by 0. If I do receive a better division exception, I can now inspect and say, well, show me the message, show me what division was attempted, and then show me the stack trace. Show me exactly what happened, right? Where this was caught, and so I can go and find it and fix that. Otherwise, if I get just a regular divide by 0 exception, I'll display divide by 0. Or something else happened, we did something else. Display that. So now, because I have my better division exception being thrown up here, and I execute this, let me get rid of that one. Now, I get my message, unable to divide by 0, right? That was here, the default message that was being reported. And I'm outputting, well, here's what was attempted, right? And we can even, right? Division attempted. And, right, this could be dropped into a log message somewhere. And then I'm outputting the stack trace. Now, notice the stack trace for this exception starts at the divide handled, right? It starts inside of here is where it was fired, right? And it does actually this here. This is .NET Interactive executing this block. All right, so I know here's .NET Interactive executing it, right? That's as far up as I can walk, and that it knows in the stack. If I remove these and let it go again, we've caught divide by 0 exception, and right, look at, now I get all the way down through all of the interactions with decimal and division and the code analysis, all the way back, ending up back at the top level of .NET Interactive here inside my Jupyter Notebook. So these are ways for you, right? And if I, just to finish this off again, right now I get a null reference, invalid operation exception. As your applications get more complex, you will need to communicate better these exceptional circumstances. And it will make more sense to create your own exceptions and handle and provide guardrails like this that inspect these methods and behave appropriately. Because clearly here, I didn't actually throw the exception here. I'm just returning, I'm logging that information and behaving appropriately after that. You're right. I see that. Guacamole. Nice. Nice. You're right. Too many programmers think that throw is the same as throw exception. You're right. So if I say here, throw E, so I'm throwing that exception, right? Notify that, hey, this thing occurred, and I execute that. Well, I'm throwing that exception, and it's throwing from here, right? There's the exception, and here is I'm back into .NET Interactive at this point. I don't need this information, but if that's higher up inside your application, right? That's further information in there. Well, now you can see exactly where it was called from to start that. If I get rid of that, right? Now it stops right where it was thrown. Okay? It doesn't go any further and all the way down into all the things. All right? So, there's... you're kidding me here. I'm off the tabs. There we go. Way back down here. All right. Yeah, I lost what was written in there. Yeah, when you use throw with that exception, you swallow the stack trace. The stack trace that happened above this disappears. But if I add that, you see I get additional information about exactly where I am. It carries that forward. All right. So just different ways to do things, and gives you a different way to be able to handle, right? Particularly if you're creating your own exceptions and you're throwing your own exceptions, you don't necessarily want to carry along the entire stack trace. You want to stop right where that occurred, right? There's no reason to pass all of that additional information along. Let's see here. Shy Sharp asks, let me put this up here. I'm not sure the context of this. Help me out here. Is argument 2 is null better? I think you're asking about doing a little bit of pattern matching there. To each their own. This is going to be slightly faster because it's doing pattern matching instead of a double equals and testing against the value. So, Boomy, that's a fine question. Is this the right time to explain how to read the stack trace? I remember in my first years of coding, it was just an intimidating wall of text. Let's do it. Sure, let's talk about that. So the stack trace that the exception has, stack trace, right? Exceptions have the stack trace in it, and the stack trace, right, is the complete list of methods that have called down into what was executed here. So, right, I have this try here that's executing this. Well, I could call this, right, try dividing, right? And if I execute that now, I have to actually call, no. There we go. Try, scroll down, show me the thing. There we go. Try dividing, right? Now, look at the stack trace. We're in the middle of divide handled, right? This method here, right? And it would give you it would give you a line number where that actually was thrown. But it was called from try dividing. And, right, I can even wrap this up. Right? Do the divide thing, right, to create another entry in the stack. Do the divide thing. Now, interesting, it isn't showing me, because it isn't showing me do the divide thing. But when I did the throw here, right, it's bringing the entire stack. Divide handled is the method where it occurred in, but try dividing was this method with the try catch. Do the divide thing, right, was the next one up the stack here. Here's the execution of the line there that actually, right, created the problem. And end of stack trace from previous location. Here going down, right, through here, this is .NET Interactive at this point. Right, this is wrapped up in how it's being parsed and handled in .NET Interactive. You don't end up with this double stack like this in a typical application. In debug mode, it does show line numbers. So we haven't gotten into building an application yet. We haven't even gotten into building an application. We're still working on basics of the programming language. But when you build an application, you can build in either debug or release configuration. In debug configuration, it will show you the line numbers in the stack trace. Right? I want to put another entry here on the right to walk down this stack. Fritz says divide. Right? I don't feel like typing. And it still stops right there at the previous thing above it. But you see the complete stack when the throw occurred. And if it, right, because it's throwing here, if I say throw the exception and we execute that, right, it cuts off. Try dividing, do the divide thing. Fritz says divide, right? But it doesn't even show you divide handled, right? Where there it is inside of divide handled. So you always want to throw, typically always want to throw without specifying the exception, unless you do want to cut off information about where that occurred. That's okay. All right. We went through a lot today. A lot of concepts. That's the end of the workbook that I have for us today. Try tinkering with this, and you can see exactly how it cuts off the stack trace and what it does with it, right? The fact that I've now created this stack of methods that it's calling into, right? Fritz says divide, executes this method, which actually calls do the divide thing, which calls try dividing, which actually does the throw way down here and shows you both the stack trace, which only sees up to the method that called it, right? Because this stack trace inside of here doesn't know about these and that and this. It's when it completely unwinds, right? When that throw comes all the way up to here, right? So let's do this. Watch this. Catch exception E, display E stack trace. Now, right? So there's where, let's say display Fritz divide stack trace. Right, so now, because it unwinds all the way out to here, now I see the entire stack trace. Now I see all the things that are in it. Versus, right? Right, if I say throw E here, right? I still see all the things. Right? But the divide handled is cut off. So this is a critical concept. Okay. You want to be able to show exactly where it reached down into that created that stack. Otherwise, when you throw it here, you lose that syntax, that context of where it went down into. All right. It's kind of confusing. So, and there's a lot of different ways that when you do encounter these, there are in a lot of the .NET frameworks, there's built-in ways to use the logger, the iLogger object, that will automatically, you can say log error and pass in the exception object, and it will log it appropriately to maybe system event log. Maybe on a Linux machine, it'll put it into the system log messages, right? And place that appropriately for you, right? You can configure that logger to have all kinds of different destinations, but logging and passing that exception object in will behave and locate that data appropriately for you about that exception. All right. We've gone through a lot. I'm going to save this off. I will update this. I'll add some other links into the notebook that are appropriate for documentation purposes, so that you can link through to the various exception documentation and whatnot. But I want to make sure you check out some of the other episodes that we've had here. And I want to talk about what we're going to do going forward into our next episode, and some of the other things that we're going to be discussing here. The next episode that I wanted to get into, I believe, is dependency injection. Now that we know what abstract classes are, now that we know how to interact with interfaces in those abstract classes, I want to talk about dependency injection and what it means, which gets into a little bit of class design. because you're going to start to make these very complex architectures, and you're going to pass them around into and out of various methods. And there's things that you can use, like a service locator, that'll provide the dependencies appropriately to you inside of your application, inside of your classes, when you call for them. And it's a whole discussion that we're going to get into next time. There's a pull request out here that I've been reviewing. I'm getting ready to merge in here. It's from Nikki Farov. I'm not sure I'm pronouncing that right. That will allow you to run notebooks locally inside of Visual Studio Code using dev containers. So we should have this reviewed and integrated before next time, but you can continue to run things over on the web. We are going to be moving, in the next few weeks, we are going to be moving to be using Visual Studio Code and working locally using VS Code as we start getting into some more complex things and we get into the user interface framework discussion. But for now, I think we can wrap it up and we can talk more about the things we learned. Let's review. So abstract classes, interfaces, there are ways for you to provide hierarchy, for you to define exactly the structure, and as your applications get much more complex, for you to define some common tools, some common methods that you want to share across classes so they can be reused. You have classes that have the same footprint, that do the same things. You want to make them adhere to an interface. You want to have them all implement the same interface so that they can behave and provide the same feature. And we saw that with iLogger, and I had a database logger and a display logger that would just log entries to the display. But they had the same signature because you want to be able to log errors appropriately and always log error with the same technique. And we'll see with dependency injection how you can swap those out easily as you're building and interacting with your application. All right, friends. I am going to get ready to edit this down, update our notebook appropriately so that it has all the latest features, and I will commit that, and it will be available out here on the GitHub repository. For those of you watching on YouTube, check the description below. All the questions that were asked, they're linked there so that you can click through and jump back to that question. You'll find that in the other videos in the series. Especially, there's a video that's going to appear right here, right next to my finger on the YouTube cards. You can click that, go back to the previous videos in the series, and even into the playlist. There's another link. It should be somewhere up here so you can look at the entire playlist. Thank you so much, friends. I appreciate you watching, and I hope you come back and tune in on Monday next week for our next episode.